As you already mentioned, I'm from the company Schickhaus. I'm a solution architect and pre-sales engineer there. My history is some backgrounds in Formix, so Central, IBM, and Schickhaus. What I want to present to you today is ETL with Hadoop and Hadoop with ETL. I hope we are quick with the slides, and at the end there will be a live demo which really should explain to you how we deliver Hadoop without Java. That's the main purpose. Let's go back in the past. So 1956, everybody now is talking about big data. Big data in 1956 was looking like that. And if you do the same thing today, this is easily what could happen. That your DC-10 has some issues in transporting 1 petabyte with this IBM racks. The company Schickhaus is pretty old. Our roots are in the mainframe area. This will also be one of my topics, how we could integrate mainframe data into Hadoop as well. The company is nearly 45 years old, meanwhile, so older than most of us here in the room. We have a lot of patents in terms of sorting, and in the mainframe area we own over 50% of the sorting market. The rest is divided by CA and IBM. So what we did there is exchanging the native mainframe sort, the F sort called, with the Schickhaus sort. Something similar we did for Hadoop. So our company contributed a sort plugin to the Apache framework, which was accepted earlier this year, which enables everybody to use third-party sorts instead of the native Hadoop sort. The native Hadoop sort is not that fast, and there are now other possibilities. Of course, we work together with all the big vendors in that area: Cloudera, Hortonworks, MapR. So everybody who is using Apache 2.0 gets our plugin automatically. For earlier Apache versions, we could install the plugin separately. From a Hadoop conference in Amsterdam, I took that slide, mentioning some stuff from Gartner and from Hortonworks. So I think everybody agrees meanwhile that what Gartner says here, that most of the big data or most of the analytic data will recede sooner or later on Hadoop. So Hadoop is a growing market. Hadoop is growing more and more, especially because of the cost. So if you look here, $100 for a terabyte in an enterprise data warehouse, and if you would do the same on Hadoop, it's just $500. So this is dramatically saving on money, and this is very interesting for companies today. How could be a potential architecture look like? You always will keep the traditional sources, they will not die. You will have new sources like social media, Facebook, whatever you have here. We can pick up both as an ETL layer. ETL is extract, transform, and load. Push that into the existing world and also in the new world, Hadoop. And then on top of that, you have all these applications or whatever doing the analytic stuff on top of Hadoop. We already contributed, that's what you asked for earlier. So these are just some of the numbers which are responsible for exchanging this native Hadoop sort. Just that you get the complete picture here. So how we do that? Why do we think we're smarter? So Hadoop integration, and let me go back, everybody in this room I think is familiar with that. The basic idea of Hadoop was not to move a big chunk of data to the application anymore as you do it today if you have your Oracle, your DB2, whatever database. It was the other way around. So we want to move the small chunk, the application, to the data. And this is actually what we really do. Some other admirers of us, what they do, they send scripts here. What we do is we have an installation on each of the Hadoop nodes. So we have a physical engine running there in the map and reduce area, but we don't use the Java libraries there. So we take our own engine, as we would do in a typical client-server installation. No coding, no Java. That means we have a graphical interface. What you generate is a program in a graphical way. You transfer that program to your server, which sits in the map introduce, and it will be executed there. So similar to what we heard before, that you can have map, that you don't need to have map introduce, map introduce, map introduce. You can build similar things here as well. And on top of that, you would use something like Hive. We are also able to accelerate Hive in terms of preparing the data much faster in our own engine as you could do it with Java. The footprint is very small. The typical executable for Linux is about 80 megabytes. You could use whatever mechanism to distribute that on whatever nodes. The only daemon which is always running is on the name node. The rest is sleeping, and the name node is then, when the name node is executing something, it's waking up the other daemons. The thing is, we have an optimizer in place, and this optimizer is able to handle not just vertical but also horizontal scalability. That gives you the opportunity not just putting box after box, so also scale on a box level. That means if our optimizer thinks, oh, I can run that in parallel, several processes per process, he will do that. Of course, even if you use a very small Linux box, you can run more than one Java virtual machine. But that takes, as we have seen, a lot of time to start that. This is not the case with our engine. The engine is there, and if it's asked to execute something, it will be executed. We have no database in the background, which is necessary for us. We're completely file-based, so it's easy to do version control with that, to do check-in, check-out, and there's no administration necessary to administer a DB2 on Oracle or whatever database. It's simply files. The good thing is we have a connection to nearly every source, especially to mainframe, as our roots are on the mainframe, so we don't need any connection software to be installed on the mainframe. We can translate what could be a nightmare, the ABCDIC language there into ASCII on the fly. This is just a checkbox you set, and then we can translate that. We can extract and load to and from Hadoop. So not everything stays in Hadoop. Some stuff has to be extracted again. We can do that easily. And everything else we can do the pre-processing and the compress, where we are very strong with, and support Hadoop and the storage on Hadoop. We have a company, maybe you're aware of Comsysto. It's an American company doing some internet analysis for their customers. And they use our software to load their Hadoop system. And they save on a monthly basis 75 terabytes of data. So that's dramatic money what they can save just by using the compress feature and other features. What are most organizations use Hadoop for? They collect a lot of data, they process the data somehow, and they distribute it. That's the typical usage. That's nothing else than ETL, as you do it today on client server. You have different tools for doing stuff like that. Could be hard, especially if you have to do that via shell commands or with Flume. It could be even harder if you have to use Java. You have just to rely on HiveQL. We have seen that's not always the fastest possibility. Also, Pig, it's a possibility, but it's not the best and fastest thing to generate the Java stuff. And also the distribution is not that easy. Another point are the costs. If I run a mainframe box today, I have some benefits, I have some disadvantages, but one of the biggest disadvantages is the price. Up to 100,000 euros or dollars for a terabyte of data, that's ridiculous. Even on the normal distributed world, it can be easily, if you take a P7 from IBM or so, it's $80,000, or up to $80,000. Also a lot of disadvantages. If you use Hadoop, you have just benefits, you're cheap, and you're very scalable. So that's why everybody now, I think, understands Hadoop is the upcoming platform. Especially if you run mainframe. So there are some research companies which claim mainframe is dead. That's a lie. Mainframe will never die as long as we have big banks, because all their important data sits on mainframe. But they need to integrate this data in the more modern data warehousing process, in the more based on social media, etc. based process in data warehousing. So we can easily connect there, no software required, that's cheap. I'm not sure if everybody's familiar with the mainframe, but the problem of the mainframe is each and every process you execute, IBM is charging you for. So you think twice if you run a query there or not. And yeah, the more MIPS you use, the more IBM is smiling. That's all. It could be very expensive. The translate, that could also be a problem. Epsidic is nice. I show you an Epsidic file afterwards in the demo. That's could be a nightmare to translate that. Especially in the mainframe area, you have stuff like packed decimals, you have occurs, you have redefines. So a COBOL copybook, which is the basis for the mainframe stuff, could be that small, but the result can be that long. And if you have to code that manually, that could be a nightmare. Loading the stuff, unloading the stuff from the mainframe, loading the stuff into HDFS, and do the processing there, it's much cheaper for customers, and that's why they have a lot of interest in transferring and offloading the data from there into Hadoop stuff. What we have is, we have 5 core transformations. This is something like join, aggregate, copy, merge, and based on those transformations, and guess what, all of them require a sort somehow. You can't do an efficient join if you don't do a sorting on the data first. You can do everything you need to do on this based on these transformations. Inside each of the transformations, you get out of the box functions, all the text functions, all the conversion functions, all the to-date, to-text, whatever function you need to manipulate the stuff. And then you develop that locally on your Windows machine and deploy it later onto Hadoop. Or you deploy it immediately. So we will see how this is working afterwards. The good news for all the people which have no Java skills is you don't need Java skills to do that. There's absolutely no Java involved. There's no Java virtual machine involved. There's just our engine. And all you need to do is design a graphical process and transfer that to the engine, and you can run in map and reduce. Coding is optional. You can code, of course, if you want to, or if you have something, we can integrate that, but it's not necessary. Smarter productivity. What we offer, and you will see the download address afterwards, what we offer is a complete prepared image for Cloudera and for Hortonworks, and you can download that. You get a 30-day free trial key with that, and then you can play around with that. Of course, you have no idea upfront how to do that. That's why we deliver what we call use case accelerators. So these are pre-defined map and reduce jobs, HDFS load and extract jobs, etc. Everything you need in the area of aggregation, change data capture, joins, and connectivity to the mainframe. And you can play around with that. They come with data, so easy for you to play with that. It's free for 30 days. And you can make yourself familiar with the stuff. What we will see today is how we read data from the mainframe. Of course, I don't have a mainframe here, so I have just the Epsidic data. There's a Windows emulation for mainframe I learned last time, so it's working, but I don't have that. But how we read the Epsidic data, how we load them into HDFS, and how we run a map and reduce job doing CDC. That's the demo. A potential issue with if you just transfer scripts is the Kerberos and Ldap integration. Especially banks have the need for security. And if you just transfer scripts, that's not that easy. We have a customer, a small bank in the United States called Bank of America. They tried that for 6 months with a legacy ETL tool. They were not able to do that. Then they tried it with an open source ETL tool. They were not able to do that after 2 weeks. And then we came in, and after 3 days, all map introduced and all Hadoop was working. And Bank of America is now one of our biggest customers in the Hadoop area. This is the download address, www.syncsort.com/try. You simply register there. The registration is necessary that you get the license file that's sent by email to you. The image is about 4 gigs. It comes with all the necessary software. The Hadoop side is pre-installed. All you need to activate is the license key. And then you need to install on the Windows side the client. You get all the stuff in terms of the use cases. I will walk you through that in a minute anyway, then you should be more familiar with that. We have some benchmarks. File CDC, so this is a DM Express job. If you double click on one of the tasks here, you get to this inner life. This is a map and reduce job. If you write that in Java, you have 149 lines of code. If you write it in PIC, you have 70 lines of code. And this is all you have here. It's a graphical job flow. Weblog aggregation, pretty simple. 2 tasks, 2 aggregations. This is all you have to define inside the group by statement and the summarize statement. It's 94 lines of code in Java and 48 lines of code in PIC. I think this is pretty much easier. Also in terms of performance, you should be familiar with the Kerberos benchmark, which comes natively with Hadoop. And if you look at the numbers here, the improvement numbers, the more data we're talking about, the higher is the improvement using our sort and using the DM Express platform. I have the same for file CDC. Here are the numbers even more impressive. If we talk about 148 gigabytes, we are 72% faster than the native Java and PIC stuff. So this is a dramatic improvement of performance and helps also Hive at the end to get faster to the data if we prepare them. Weblog aggregation, here again we have numbers between nearly 20-something% up to 60% depending on if we did it with Hive or with Java or with PIC, or if we have more or less data. Of course, if you just run it on just a small sample, the benefit is not that big. Questions so far? Yeah?
All the ETL tools are, in my opinion, 2 categories. One is generating inside a code.
Mm-hmm.
Second is generating a file, for example, some file which is afterwards interpreted. So these 2 types of ETL tools is one generating behind Java code, for example, or another type of code. The other one is just generating some sort of template which is afterwards interpreted when running the ETL job. Which kind of these 2 is Singsoft?
The tool DM Express from Singsoft is a company, has or is generating an application, and the application is transferred to the engine, and the engine is executing that. It's more an interpreting engine. It's no code generated and no code transferred.
I will rephrase it. When I would like to put it to like the source of the generated job, or the generated mapping, what would I obtain when after I would, let's say, save this mapping? I would obtain
You get a file.
a file which kind of?
A normal file. It's not really readable because there are some binaries in there, but it's a text file.
It's text file. It's like an XML. It's like some sort of attribute-based.
Yeah, it's not. You can't edit it. You can open it, but you will not be able to read everything. As I said, there's some binaries in there as well. But at the end, it's a text file. We have 2 types of files. We have. Let me go back. If you look at that, this is a job consisting out of 2 tasks. So you get a file per task and one for the job containing the 2 tasks. So what you will have is 3 files, and those 3 files are stored on the engine side afterwards and executed there. That's answering your question?
Yeah, I think so.
Yeah. So it's not possible to go to the code and edit the code and change it. If this is the question.
Yeah, but generally, if I have one parameter which I would like to put there, I don't know, so the global configuration parameter, I don't know, database password, can I encode it?
That's part of the whole solution. Of course, we have those tasks or template kind of approach just to do that. So if you develop something in a test or development environment, the database access might be totally different than productive environment. So of course you don't want to change the whole job. All we want to change is give another parameter file with that, or simply call that job with different parameter content.
There is one job scheduler or one, let's say,
It's yeah, we have a job scheduler integrated, or you use whatever is existing or whatever the customer has. So we are command line based, so you can execute DM Express exit or .sh, job name, parameters, run it.
There is an interface for the administration of the jobs, for example.
Yes.
To see
Yes.
how
We will see that during the demo. Yeah. There are actually two. You can use the job tracker interface, which comes with Hadoop, or you use our interface.
What are competitor products you see on the market at the moment for such graphical ETL tools?
Graphical ETL tools, there are a lot of on the market.
For Hadoop, for example?
Some of them already support Hadoop, like Informatica, like Talent, like Pentaho, and so on. The huge difference between all of them and us is that they all generate scripts, and they transfer scripts, Java scripts. So one reason why there are graphical tools on the market is to get away in old times from the SQL nightmare. We have A4 pages of SQL code, and now we go to A4 pages of Java code. And that's not what we do. So we have purely no Java to get that done, what you want to do in map and reduce. They do it. The problem, what we see there is, you can, at first it's slower, because it's not, a generator is never the perfect code. Then you have some experts, they edit the code, and then you lose the connection to the graphic anyway. And then you pay a lot of money for that. That's, yeah, not really what you want. We are not free, of course, but we're pretty cheap compared to other competitors. And yeah, we are not developing code.
So here I would say that Pentaho is not doing that. I mean, I don't know what, how potentially performant are, but we're generating XML. XML is interpreted afterwards by application server, and this is really a code interpreter. I think somehow very similar to what's doing.
But at least the version I know of Pentaho, they are not running an engine on the Hadoop in the map and reduce framework. So they still use the Java code there.
For example, Talent, it could be our colleague is not here. I think Talent is already somehow taken over by Hortonworks, and I think it can be run on the nodes. But I don't know. I'm not Hortonworks investor.
Okay.
Why do you think banks are never going to give up mainframe for storage?
Because mainframe is something so reliable, what other machines will never be. I had the opportunity while I was working for IBM to see the factory in Montpellier, where the mainframes are constructed actually and tested. Then they are deconstructed, sent to Ireland, and from there they are shipped because it's cheaper and tax reasons. And the guy who showed us the factory said, "We are so happy that the users of IBM do not use the mainframes till their end of life, because then IBM already would be bankrupt." So machines easily run 20, 30, 40 years without any issue. So
It's just the workforce aging.
yeah, it's they are so reliable, and most applications. A lot of companies use databases like IMS, IDMS, Adabas. You may have heard of them. They are hierarchical databases, and it's not that easy to get away from them. There are tools on the market to do that. Comsysto bought a company called Circle Group, which is able to do a migration from IMS to distributed world. But that's just IMS. And it's all the application, all the big banking applications, all the tracking mechanisms for stock markets, etc. They're based on mainframe, and you can't exchange that like this. It's not like in the distributed world where you simply buy a new application and exchange it. It's a homegrown stuff over 20, 30, 40 years, and everything is based on that. Even companies like SAP have some roots already there. Something like cluster tables, for example, comes from the mainframe. Because of the restriction of number of tables on the mainframe, they brought something up like tables and tables and tables. And they still have it today. So it's even there, it's not easy to exchange their stuff. That's simply homegrown. And they are very, very reliable. Okay. Let's jump to the demo. Before we do the demo, some small explanation that you understand what you will see. The typical process if you run a map introduce job today is you have a mapper program, you run the map sort, that's a kind of closed session, you have to use the Hadoop sort. You run the reduce merge, which is the equivalent of a sort again, and then you run the reducer program. That's very high level, a typical process today. We changed that process. What you see here is the equivalent of the mapper and the map sort. Here's the sort done, here's the mapping done. And of course you can do as many tasks before that as you like. And the second part here is the equivalent of the reduce merge and the reducer program. And again, you can do whatever you want here. Everything your fantasy tells you to do, or your data logic tells you to do, you can do here. What we do here in this case is we read, and this is exactly what you will see afterwards, except that we meanwhile have done that in one task. You read two episodic files, which could physically sit on the mainframe. You combine them, you sort them. Here you generate the unique key stuff you need for the map introduce part. Here you divide them again, you do a join to determine is it an insert, update, or delete. And you write that back to the HDFS. And on top of that, you could run something else, extracting that from HDFS again. So it's pretty simple. To write a job like that, it's absolutely not more than maybe 20-30 minutes. And then you can already run it. Exactly this job you have in the use cases. This one you can run after the, and unzipping the VMware image already. If you like to, you can use your Java upfront or afterwards. If you have something what you want to use or you have to use, there are also some homegrown stuff which can't be replaced. Okay, use it, but it's not necessary. More simplistic view on that. Here we perform the logic inside our tool, inside the engine. This is what we replace with our sort. Here the plugin comes into the game. The shuffle, then the input sorter, again our sort, and reducer, this is the logic we perform inside our engine. And here you can do whatever you can do with ETL, or what you would do today with a Java program. The example of Comscore I mentioned earlier. Here we have two sources, Teradata and flat files, mainframe flat files, 32 billion records a day. So a really huge amount of data. DMX is loading that into HDFS. Before we load that, we partition it. That's automatically done when we connect to HDFS. We compress it, we sort it, and then it's loaded to Hadoop. And on top of that, here we do the extract to Teradata again, and on top of that, Comscore is then doing the analytics. So a lot of companies use Hadoop as a storage meanwhile, as they do. They did it before with Java, and the CEO of Comscore gave us a statement that after using DM Express, he saw a 500% improvement in throughput just loading HDFS and extracting HDFS. What is a huge benefit for them? We have some companies in the US, and I'm quite sure this will come in Europe as well. You go to a football match, so American football or baseball match. So you leave the game, your team, your home team was the winning team. So when you leave the stadium or the arena, you already get an SMS. Oh, congratulations, your team has won. Oh, by the way, next week there's another game and I have tickets for you. And you can already subscribe for the tickets. This is just working, and there's some surveys they did, 15 minutes after you leave the game. But the amount of data is incredibly huge you have to go to work with. So those companies were not able to do that. Now they are able to do that with Hadoop, and some of them already use us to do the processing there. Good. Questions? Otherwise we go to the live demo. No? Good. So hopefully you can see that. First of all, this is my VMware running my Hadoop. What you have here is, and this is important if you download this stuff, You see this preparation script here. This is what you have to run. This is the most important thing once you install the VMware. Run that preparation script because that's extracting everything internally, preparing your data in terms of moving everything to the right place that you afterwards can use it. I did that already, so this is done. The next stuff here is, I will show you that later, that's already my, let me see here, my target directory, which will be empty except the supplier.dat. Supplier.dat is one file I would need for another job, but we don't run that job today. And we will see that it's filled afterwards. And what's also, maybe interesting for you is this COBOL copybook here. This is the source, the metadata source for an AppSedic file. You see you have compressed data here, PIC, and so it means text and number files. So this is basically what you get if you work with mainframe. If we go back to, let me see, let me open up another one here. I like Windows. If we go to the use case accelerator directory, below that we have bin, there's a preparation script, we have data. And below data we have two important directories. One is source. And in the source directory what you find is, for example, this one and this one. These are our mainframe data, our mainframe files. So if we try to have a look at them, that's not very readable. This is AppSedic. So good luck to translate that with Java. But can be a nightmare, especially AppSedic files, sometimes segment oriented. So there's a bit somewhere that tells you, okay, you have now 5 segments, and in the next record you have 10 segments. So it's really fun if you want to work with that. So what we want to do now, and now I'm jumping to our graphical interface. This is a complete job reading the mainframe data, loading them into HDFS, and this job, let me open that by right-click, edit job, and this one is, it's a little bit big, is then doing reading the 2 files which we stored in HDFS, is doing the sort and the combination of both, generating the keys which are necessary. This indicates that we run a map and reduce job. We split them up again, because what we want to do is we want to make a determination, do we have that record already have yesterday, yes or no? If yes, and we don't have it today, it's a delete. If no, and we have it today, it's an insert. If we have both keys already in both files, then we have changes in the values, then it's an update. That's pretty simple, done by this join. And what we later on will see on the VMware is the CDC results directory containing all the parts and the chunks of the files we produced. So this is basically what we run there. If we now right-click and edit task, just a pretty simple one, reading that file, so it's of course asking me for the connection details, and hopefully you can still see that a bit. You were asking for parameters. This is the usage of a parameter here, because of course I don't want to change the source directory, which could be different on development than on production or even on test. So everything with a $sign up front, that's a parameter. So here we read that file, which I showed you earlier. Here's the parameter, you see the full path here. The file type is a mainframe, fixed record length, the byte length, character encoding, etc. Target, it's already on the HDFS side, so the DMX test drive, you see HDFS data target, that was a directory I showed you earlier, which was just filled with the supplier.dat. And here you see the metadata, and the important thing here is how easy it is to connect to an HDFS system. So all we need to do is, and again we use parameters here, to make a selection which server you want to run. The GM Express server, which is the native server on Hadoop. And here you select something between SFTP, FTP, or Hadoop distributed file system. That's all you need to do. Of course, we want to run that on HDFS. Then we can verify the connection, and hopefully we should get a positive feedback. The connection is valid, so we already have a connection to HDFS. You get the help then here with this green ball, which indicates, okay, we are connected. That's pretty much it. You see here the 5 tasks: aggregation, copy, the join, the merge, and the sort. On top of that, you could do filters, you could do reformats, which is the T part, the transformation part. I can show you some reformats here. In this case, we simply fill a field with empty spaces, with spaces, and the rest we just do some renaming of the columns from the COBOL copybook to the original file names. The same stuff is done here, and when we jump here, we read the files. We did put on HDFS already. You see the same principle. The source, this time it's the HDFS data target directory, the line items previous, the line items current, the 2 files. The key is the partition number, which is generated here with a pretty simple function, which comes out of the box. The CR32 hash function is based on the DMX Hadoop num reducer, so we take the number of reducers, convert that to number, and do a hash function with that on item full key, which is one of the keys, or the natural keys, and then we have a unique key which we need. All the functions I'm talking about you get here out of the box simply by selecting them. Date functions, here's the CRC32 function, lookup function, number, and also, and this might be of interest for you, you can use your Java code here as well if you want to call that. So something you have developed and it's very important for you, you can't replace it. We have customers which use a lot of C or C++ functions. They can't replace them immediately. They simply keep them for now and call them via this interface. I think sorting is pretty simple. You select add key, then you select whatever field you want to have for the sorting. In our case, we have the partition number. We want to retain all, or we could retain only one. That's a kind of unique sort. Pretty simple to do that. And again, we have the HDFS connection here, which is necessary to read the stuff. This indicates, so I could use direct data flow or not. So we use direct data flow here. That means we don't have to land it to disk. It's a kind of, yeah, you mentioned that with the streaming. So it's, I don't know if you, someone mentioned that with streaming. It's not the streaming you meaning, but it's a streaming from map to reducing. So there's no need to land it to disk. Here we split the files up again. Let's have a look here as well. We split the files up again based on a filter. And the filter is based on these conditions. Either I have a current file, then I put a C in that column, or I have a previous file, a record from the previous file, then I have a P in there. That's a simple thing you need there. You put the data based on this filter to the 2 branches here. The join then is also pretty simple. The join is done on the appropriate keys, and based on the condition that we have an action code which is not empty, and the action code should be new, delete, or update. And this is determined by join, which is a full join. You take the output match records, you take the output, the unmatched from left and the unmatched from the right side. So you get the full result there. And this is pretty much it. To build that join, select the key from here, select the key from here, and then you have done the matching already. The result is landed to disk in the HDFS framework, and now what we want to do is run that job. I click on run, you get the selection here, run it on server, that means run it locally, or on every server you want to run that. All I need to do to run that on Hadoop is, I want to run it on Hadoop cluster. This is the data directory, this is the server, the test drive. We compress the temporary word files to save some space. Here is send email based on completion status, so you can react on the log file whenever you want to do that. Or here we can schedule the stuff as well, simply by selecting schedule. When I click start, I get the log file window, which tells me that the job is running, that the elapsed time, and at the same time you can start this. I can keep both a little bit so that you can see both, so it's still running here. And if you double click on that, what we get then is the content of the log file. So you see immediately, okay, we read nearly 10,000 records. This is the amount of bytes we have read. End task, the DMX Express task, is completed, so it's completed in 8 seconds. And the second task, reading the second file, is also completed. And now the map and reduce job is starting. And if I jump back to this browser here, then you should see, as soon as mapping and reducing comes up, as it happened now, that you get a running job, and you see the mapper and reducer. And if you set that to, let's say 3 seconds, which should be good enough, then it's refreshing itself. This is coming from Hadoop itself, that's not our interface. So then you see here in a graphical way, if you use Google Chrome, Internet Explorer is not able to display this graphics, that the mapper is already 42% done. The reducer is still waiting, and so the mapper is 100% done. Then you get all the statistics based on that. You can also drill into that a bit more and see we have 2 mapper tasks running here, or have had running them, and you get all the necessary statistics you want to see there. Let me go back. Go to job tracker again. So the reducer has already done 66% as well. And back to, I don't know why it's always ignoring my settings here. And now the reducer is 100% done. And if we then refresh our log file, what you can see then, the mapping progress, the reducing progress, and the total elapsed time for the whole job, reading the mainframe files, translating them into ASCII, loading them into HDFS, doing the mapping and reduce part, make the CDC part, and load it or land it to disk again in HDFS takes about 2 minutes here. If we now jump back to this window here, and I think it was the first window, if I simply rerun that, I see then that I have generated here a directory called CDC results, and in that CDC results we have the chunks of the result file. So this is what you would use afterwards to query it with Hive, or to extract it, to load it to Teradata, or whatever you want to do with that stuff. Okay? Questions? I think we hit the point, 8 o'clock. Yes, of course. Yeah. Yeah, you can run whatever you want to run there. The thing is, for a demo, it does not make sense to make it more complex than it is, but you can.
Mahout library. Do you have a Mahout library besides
What do you mean by that library?
Mahout. Mahout is a data mining-based clustering, machine learning-based
recommendation engine.
No, we have our libraries or our jobs. We have nothing to do with at least I don't know that. Sorry. But.
So you told about reading from mainframes.
Mhm.
What about, for example, ODBC database connections or JDBC database connections? So does it use then the power of Hadoop, like distributing the database calls or something, or how does it work?
So what you definitely can do is, so where I have the files here as an input, I could have each and every database. Doesn't matter if it's Oracle, Teradata, SQL Server, whatever you have, as long as the database has a native interface, like Oracle DB2 has, we use the client. If not, we use the ODBC connection. For some database like Informix and SQL Server, ODBC is kind of native access to the database. And yes, you can do that here, and of course you can extract from HDFS again and write that to that database back as well, if necessary. Depends on your logic. Yes. Okay? Other questions? Again, if you want to play with that, go to our website, /try, download the image, play with it with 30 days for free, and you get I think you get a quite good feeling. If there are questions, you got my email address, should be part of the invitation as well. Just drop me an email, and I'm available to answer questions like that. Okay? And thank you.